Alright, hello everyone. In today's video we are going to go over an op-amp question. Specifically, we are going to figure out how to characterize this current I0 coming out of an op-amp in a circuit where there are a total of 3 op-amps. So, some quick rules, reminders from previous lessons. For op-amps, V positive is equal to V negative, and the current going into V positive, into the positive terminal is equal to the current going into the negative terminal, and they're both equal to 0. And that's about it. Those are the assumptions. So right off the bat, we can kind of see, 6.98 volts here, then this V negative must also be 6.98 volts, but there's a short circuit all the way to the output side, therefore over here it must also be 6.98. We can say the same thing about the bottom circuit. So there are the 7 volts and the 6.98 volts. And now what we can do is we can try and characterize this V positive here. And we can do that pretty easily by using a voltage division equation. So we start with the 7 volts, which comes from there, and it gets divided down using this voltage division resistor network here. So 40K on the top over 60K on the bottom, which is the sum of the 20 and the 40, and that'll give you V positive. And the reason why you can do this, even though it's connected to an op-amp here, is because the input resistance, if you remember, is infinity. And so it's ultimately like it's an open circuit with respect to the analysis of this little network over here. So we have V positive, therefore we also know what V negative is. And now that we know what this node here is, that voltage, and this one, we can continue to try and find I0. So for us, we'll go ahead and do some KCL now. We'll go ahead and define the current direction, so it goes like this. Left to right across the 20K, left to right across the 40K. So we can actually write out a nodal equation here. We can say I20, the I20K, is equal to the current through the 40K. And notice that I'm talking specifically about these two up here, so I'm just going to make them blue to color code. So there they are. I'm not talking about these two down here. I'm talking about the two that are blue at the top. So the I20K, we can parameterize. That is equal to 6.98 minus V positive. So the current starts from 6.98 volts, it ends at whatever V positive is, and it goes across the 20K. So across the 20K, the way we get that is divide the numerator here by 20K. And now we know what I40K is as well. I40K is equal to I20K, which is this green expression here. So what we do now is we figure out what this output voltage is. So there's another thing that we should have pointed out at the very beginning. If they ever ask you to look for the current coming out of an op-amp, ignore them. What you want to do is first figure out what the output voltage is, because you cannot just figure out the current all by itself right away. You have to figure out the voltage first. So we're going to find what V0 is, and we can write an expression for V0 from these two here. V0 would be equal to whatever V negative is, and instead of saying V negative, I'm just going to say V positive, because we know V positive and V negative are the same. So we're going to start at V positive, and then some amount of voltage will be dropped by this 40K. So I'm going to write that expression out. So we said it starts at V positive, and then we drop some amount of voltage across the 40K resistor. And then whatever is left over, that's what your V0 is. And so we know what V positive is. V40K, well, we can parameterize that. V40K, which using Ohm's law, just be the 40K, so IR. So in this case, I'm doing R times I, so the resistance is 40K. And we know what the current is through the 40K resistor. I40K, it's right here. It's equal to I20K, which is this green expression here. So now we know what V40K is, and we know what V positive is, therefore we know what V0 is. Now that we know what V0 is, we can find out what I0 is, using Ohm's law once more. So you do V over R. R in this case, the output resistance is 50K. And that's how you'll get your final answer. Alright, thanks.